Welcome to another episode of AAP Computer Science. Be ready to take notes and learn lots. API stands for Application Programming Interface and is one of the most useful tools you'll have while working with Java. APIs show exactly how to use pre-made classes. The Drawing Tool class specifications handed out in Lesson 1 is an example of a simplified API. It lists the classes and constructors so we know which methods are available. APIs do not tell us how the programmer dealt with the problem or what kind of formulas they used internally. It just tells us what methods we can access and how to interact with those methods and what those methods will return back to us. You can always access Java APIs at java.sun.com. The Java APIs are organized both by package and by class. Packages are groups of related classes that are packaged together. When you use the code imported gpdraw, you're adding an entire gpdraw package to your code. If you only need one or two classes from the package, you can add the classes individually from your code with the import. Before you look at APIs in depth, you'll need to learn what the keywords final and static mean. When used with primitive data types, final means that the value of the variable will never change. This is useful in many cases such as tax rates, math constants such as pi, and the base values that will be used in several places of your code. Identifiers with final are generally made with only capital letters so that they are easily distinguishable from the rest of the code. A program that repeatedly uses a constant identifier, such as tax rate, can quickly be modified by assigning a value to tax rate at the top of the program. If the value of the tax rate is hard-coded everywhere else it is used, then changing the tax rate would involve changing the value everywhere it appears in the program. This involves searching throughout your program and finding every single time the value is used, and then changing it to a new value. It would be easy to accidentally miss a value or two and possibly change something that was similar but wasn't supposed to be the tax rate. Using final values not only saves time, but it can reduce the amount of errors in your program. Once a final variable is given a value within a program, the value may never change in that run. In order to change the value, you must change it within your code, recompile, and run the program again. You may still define the value within the constructors so that the value can be determined at runtime. It need not be defined at the same time that the variable is declared. Using the keyword static means that the data member or a method is attached to a class rather than an object of that class. With a static method, you only need the name of the class followed by the name of the method. You never need to create a new object when dealing with static methods. You can think of static methods as belonging to the class itself. JSON receives and restores the result of 3 to the 4th power, which is 81. Notice how there was never a need to create the object type math. Instead, we just have an int assigned the value created by the static method of the math class. Data members that are static may also be used without creating an object of that class. They also have specific behavior when using that value of a data member within the class. While we may make 100 objects from one class, any static variables of the class will in fact be shared by each of those objects. If one object changes the value of the static variable, then the value is changed for all of the other objects of that type. This is because the variable and its value do not belong to any of the objects individually, but the class itself. You've already been looking at an API for Drawing Tool. The purpose of the handout A1.1 was to give you an introduction to the purpose of the class and how to use its various methods. When instructed to draw a circle, you probably looked at the handout and saw this. If the object is in the drawing mode, the circle of radius r is drawn around the current location using the current width and color. This tells us exactly what we need to know to use this method. We have the name of the method and the type of the arguments it takes. We also know what will happen after the method is called. This is not the official Java format for an API, but it accomplishes the same thing. Without the handout, how would you have known how to draw a circle? How about when you made the picture of the house? How would you have known to use the forward method, turn left, down, or up? As you see, APIs are essential tools that must be looked at before a programmer can understand how to use a pre-made class. The Point2D class is useful for storing locations on two-dimensional spaces. It also contains several methods that we can use to do certain calculations. There are two subclasses of Point2D, but you'll generally only want to use Point2D.double. Consider an application where you need to track the location of two mice on a flat bottom box. You can use Point2D.double objects to keep track of their locations. What if we want to be able to tell how far apart the two mice are at any given time? We could use the distance formula from geometry to calculate the distance. However, if we want to take a quick look at the point2d API, we can find this method. Return the distance as point2 from this point2d to the specified point2d. A line of code as simple as will give us the distance between two rats. This is much simpler than trying to do all the calculations ourselves. Remember, whenever possible, we want to avoid writing code that has already been written. By doing a slight bit of research, we have saved ourselves the hassle of writing and then debugging code. As the name suggests, java.util package is full of utility classes that you'll find very useful. Many of them are going to be far advanced for what you need at this stage, but as you progress in skill, you should browse through the classes and see which ones you begin to understand. During this course, you will learn several of the util classes in detail, but for now we'll concentrate on just one, java.util.random. Random is probably the most fun of all the classes in the java.util package. Any sort of game or in-depth simulation will generally need some sort of randomness in order to work the way we want. Let's take a look at it now. A random creates a new random number generator. Next int returns a pseudo-random uniformly distributed in the int value between 0 inclusive and the specified value exclusive. These are the methods that you will likely find most useful. The constructor is very basic and requires no arguments. The word pseudo-random just indicates that the number is not completely random. Computers are not physically capable of creating random numbers. Therefore, in computer science, we refer to computer-generated numbers as pseudo-random. The math class in java.lang package contains the class methods for commonly used mathematical functions. Java loads the java.lang package automatically, so there is no special action required to access these. The math class contains both methods and numerical values for two important mathematical constants, e and pi. These constant values are accessed the same way as normal variables, but they can never be modified directly by your code. The math class is most useful for complex mathematical formulas. For example, using the math class, we can create a line of code to solve this calculation, much like you would type the same equation into your calculator. Let's see what other kind of methods the math class provides for us. The list shown here is much shorter than the one you'll find online. However, let's look at the layout. At the very top is java.lang, the name of the package of the class it's in. Below that is the name of the class, followed by a series of class names. You will learn more about this later, but for now just think about the classes listed as parents of the current class. Below that comes the description of the class, which gives an introduction to the purpose of the class, which allows for programmers to quickly decide if the class will do what they need. Next is a list of attributes and behaviors labeled as field summary and method summary. The field summary section contains two items in it. In the left side of the table, we can see that they are both labeled as static double. This tells us the type of variable, so we know how to use it. On the right, we see the name of the variable followed by a brief description of it. If you're looking at this on the internet, you click on the name label and be taken to a more detailed description of the variable. We don't generally need more information on variables, but the links provided by API just in case. The method summary section has all the available methods provided by math class. Once again, we can see that the table is laid out in a similar manner, with the small section on the left and the larger section on the right. With the first listed method abs, we can see the left section has the same label, as we found it on the e or pi values. However, this time it is telling us the return type of the methods. On the right, again, we get the name and a brief description, but we also get the arguments that must be passed to the method. Clicking on the name will go to a full description of methods is often much more useful than with variables. If we click on the name abs, we find much more information than we originally had with the short description. Here we gain much more information about the abs method and what its purpose is. We learn some basics about what it does to the value. It even gives us some special cases that, while rare, can still occur. Note that NaN means not a number. Here are some examples of the abs method. The basics of creating your own APIs are pretty simple. When you add comments in your code, you can use this special type before each class, variable, constructor, and method to create block comments. These comments work within your code and are essentially the same as a regular block comment. However, once we run the Java doc tool, APIs will be created based on these comments. The first line of a comment should be a quick description that sums up what is in front. The first line will turn into a quick description as we discussed earlier. The rest of your paragraph should consist of more detailed description of the item. When you run your java.exe program on your Java file, it will create a few HTML files in your local directory. If you open up index.html in your web browser, you will find yourself looking at the APIs created for your class.